Hello everyone, welcome to the course. This course name is How to Maximize the Off-Grid and Hybrid System Solar System Capacity. As you know, the sun is our energy source, huge energy source. And we try to maximize the PV system capacity, renewable energy source application to fight the global warming for the future. And we already have built large these solar farms with huge capacity. But why are we still talking about off-grid and hybrid solar system capacity? We're going to get into the detail to explain. This course is going to explain what is the limitation of the current system, why we still need to maximize the off-grid and hybrid solar system capacity. Currently, the majority of our renewable energy source come from the grid-tie PV systems. However, the large-scale grid-tie system, or we call them a front-meter system because you have the solar plant or solar farm reject energy to the grid. So such a system has a limitation. It has a benefit. You can build a huge scale, but the main limitation comes from the electrical power transmission, long-distance transmission rules, and transmission cost. Also, the energy storage. You may build a huge, large-scale energy storage system, but you still need to transport the energy, transmit energy to where it's being used. So for those systems, grid-tie system, they are high voltage system, and the solar panel has a huge maintenance cost because solar panel works under high voltage. It's likely to be damaged due to the potential induced degradation, we call it PID damage. The solar panel degrade over years. And also you try to avoid the shading on the solar panels. You building micro inverter or these optimizers. Those electronic devices, even you seal them, you place them outdoor working condition, obviously you're going to have high maintenance cost. Over years, the electronic small devices exposed to the outdoor weather condition, it will cause damage as well or degrade. And we have limited capacity of the existing power supply grid. So if you build large farms in other remote location, and you have to spend so much to upgrade the existing power grid to be able to transmit those powers to the customer where it's being used. And if you build huge this energy storage capacity in some locations, you will expecting energy to be charged and discharged each and every time. And all the battery has charging cycle, this life cycle, charging cycle limitation. Those batteries can only be charged for so many times. So if every time you want to charge and discharge, and the life cycle is going to be reduced. For energy supply, if we say rely on all those electronic components to conduct the power, inverters, charge controllers, and there's a lot heat loss. That's also energy loss there. This is why we say the large grid-tied system has its limitation too. So we know the large grid-tied PV system has its limitations, but everyone in the solar industry will know off-grid system has very little this capacity. We rely on MPPT solar charge controller, and the capacity is very limited, so not enough to power even a house. This is the reason why we come out this course, and that's idea there. The key point here is our system can be largely implemented for every household, every cottage, every piece of land, every parking lot, worldwide, like a large scale, but the system is 5 kilowatts, 10 kilowatts per system. And we use the mechanical contact switch there to power the load directly, and most of the time without even charging the battery. So our battery here in this system is barely maintain the voltage. And our hybrid solar system include both. It's off-grid hybrid or this grid-tied hybrid. So those in our system, we can have a net meter as well to pump the power back to the grid, and or without net meter. It's called behind the meter system. So this course topic is going to cover off-grid and hybrid system. Hybrid include 100% this behind the meter system and in front of the meter system. So this is the scope of a course. It's going to cover these topics. The main is to maximize the capacity of the PV system, and then this system to be implemented in every different locations to harvest, to store the energy. This is to overcome the energy shortage we are facing. We break down this course in 5 sections. The first section will be just introduction to the instructor, to the system. And the second section, we mainly focus on the principle of solar charge maximizing controller and its definition, and then what to include in that system. The third is about application and benefit, where we can use that system for. And the fourth one would be how to design and implement the solar charge maximizing controller system. The last section would be mainly focused on the installation technique, how to install the system properly, and how to form the high current capacity this connection point. Hi, my name is Wayne Shi. I'm a building service engineer with multiple construction trade background. I offer the building service engineering service to the public in Ontario, Canada here. And this course is designed for everyone with little knowledge about electrical system, electronic system. Like if you know how to use multiple meter, amperage meter, then pretty much you can understand this course. And we also teach the design, installation, and planning that may be a little bit advanced, more for professional, this solar professional, but any ordinary people with slightly electrical knowledge would be able to understand. You may not want to necessarily to design and install, troubleshoot the whole system, but at least you're gaining some knowledge to understand what is it all this about. So this course can be good for any like a homeowner, business owner, solar professional as well. And it just even you are hobbyist to solar contractors. At least you will learn what is it all about in this course. It's mainly for the idea, the principle, and the benefit of the solar charge maximizing controller system, and difference between the grid-tied system and the off-grid system, and why this system will be the answer for the energy shortage. So welcome you to join us, enjoying